think evolution takes millions of years? What if I told you we've seen it happen in just a few decades, right before our very eyes? We often picture evolution as this slow, grinding process, shaping life over geological time. But some incredible experiments have revealed a much more dynamic and, frankly, shocking truth. Today, we're diving into 3 experiments that show evolution happening at lightning speed, fundamentally changing how we understand life on Earth. Get ready, because what you're about to hear will blow your mind. Let's start our journey on a tiny, sun-drenched island in the Adriatic Sea. In 1971, a team of scientists did something simple yet profound. They took 5 pairs of Italian wall lizards from their home island and released them onto a neighboring island called Padmacaro. This new island was different. While their original home had plenty of insects to eat, the new home was covered in lush vegetation. The lizards were left alone, and for over 30 years, nature was left to take its course. When scientists returned in 2008, they expected to find the lizards struggling, or maybe even gone. What they found instead was astonishing. The lizards on Padmacaro were not just surviving, they were thriving. But they were different. Physically, their heads were larger and their jaws were stronger. This made perfect sense, as they needed more force to chew tough plant matter. But the most incredible change was hidden inside. The original lizards, like most of their kind, were primarily insectivores. Their digestive systems were built for meat. The new lizard population, however, had developed something their ancestors never had: cecal valves. These are small muscular rings in the intestine that create fermentation chambers, slowing down digestion. Why is this a big deal? Because these chambers allow gut microbes to break down the tough cellulose in plants, effectively turning these lizards from insect eaters into dedicated herbivores. In just about 30 generations, these lizards had evolved an entirely new anatomical structure to adapt to their environment. It's like a car spontaneously growing a new, more efficient engine just because it started using a different type of fuel. This wasn't a small tweak, it was a fundamental re-engineering of their own bodies, proving evolution can be incredibly fast and inventive when the pressure is on. Now let's travel from a sunny island to a much darker, man-made environment, the London Underground. When the tube was built in the 19th century, it created a series of isolated, underground tunnels. It was a new, artificial ecosystem, and something moved in to colonize it: the common house mosquito. For over a century, these mosquitoes lived and bred in the dark, warm tunnels, completely cut off from their relatives on the surface. Biologists noticed that the people working in the underground were being bitten by mosquitoes, even in the middle of winter when surface mosquitoes are dormant. This sparked their curiosity. Were these the same mosquitoes as the ones above ground? They decided to investigate. When they compared the underground mosquitoes to their surface-dwelling cousins, the differences were stark. The surface mosquitoes primarily bite birds and hibernate in the winter. The underground mosquitoes, however, didn't hibernate. They stayed active year-round in the consistent warmth of the tube. And their preferred meal? Not birds, but the rats and humans unlucky enough to be down there with them. The most crucial discovery was genetic. When scientists tried to breed the two groups, their offspring were infertile. This is the classic definition of speciation. The underground mosquitoes were no longer the same species in just over 100 years. Isolated in the tunnels of London's subway system, a brand new species of mosquito had evolved. Perfectly adapted to its artificial, human-made world. It's a powerful example of how our own creations can become unintentional laboratories for evolution, creating new forms of life right under our feet. For our final, and perhaps most famous example, we go from the grand scale of islands and subways to the microscopic world of a single flask. In 1988, a biologist named Richard Lenski at Michigan State University started what would become one of the longest-running evolution experiments in history. He took a single E. coli bacterium and used its offspring to start 12 identical populations in 12 separate flasks. Every day, for over 30 years now, his team has taken a small sample from each flask and transferred it to a fresh batch of nutrient broth. This is a bit like creating a daily survival of the fittest challenge. The broth contains glucose, which the bacteria can easily eat, but it also contains a much larger amount of a substance called citrate. Now, one of the defining characteristics of E. coli is its inability to eat citrate when oxygen is present. For years, all 12 populations of bacteria followed the same predictable pattern. They'd quickly consume the glucose, and then their population would stop growing, leaving the abundant citrate untouched. The populations evolved, becoming more efficient at eating glucose, but the citrate barrier remained. This went on for about 15 years, or roughly 31,000 generations. Then, one day in 2003, something extraordinary happened in one of the flasks, which they called Era 3. The team noticed that the liquid in this flask had suddenly become much cloudier than the others. This meant the bacteria population inside had exploded. They were growing far beyond what the limited glucose supply should have allowed. The team was stunned. They tested the flask and found the bacteria had done the impossible. They had evolved the ability to eat citrate in an oxygen-rich environment. This wasn't just a minor adaptation. It was like a person suddenly developing the ability to digest wood. It was a major evolutionary innovation, a rare and complex event that happened right there in the lab. Lenski and his team were able to go back to the frozen daily samples they had meticulously saved over the years. They pinpointed the exact series of mutations that led to this breakthrough. It turned out it wasn't a single, magical mutation. A series of earlier, preparatory mutations had to occur first, paving the way for the final, game-changing one. The Lenski experiment provides an unprecedented, real-time window into the step-by-step process of evolution, showing how random mutations, filtered by natural selection, can lead to incredible new abilities as a living record of evolution in action. So what do these 3 stories of lizards growing new guts, mosquitoes becoming a new species in the subway, and bacteria learning to eat a new food source tell us? They shatter the old idea of evolution as a process so slow it's invisible to us. They show us that life is incredibly resilient and adaptable. When faced with a new challenge or a new opportunity, evolution can kick into high gear, producing dramatic changes in a matter of decades or even years. These experiments aren't just fascinating stories, they are powerful demonstrations of one of the most fundamental forces of nature. The world around us isn't static. It's a dynamic, ever-changing stage, and the actors from the smallest bacterium to the creatures we see every day are constantly evolving. The evidence is undeniable. Evolution is happening all around us, all the time, faster than we ever thought possible. Thank you so much for joining me on this journey through the fast lane of evolution. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the wonders of science. Let me know in the comments which of these experiments shocked you the most. Thanks for watching, and I'll see you in the next video.